ये क्वेश्चंस थोड़े स्पेशल है मेरे लिए क्योंकि मैं जब ISI के लिए प्रिपेयर कर रहा था इन द ईयर 2019 आफ्टर द प्रिपरेशन दीस वर द क्वेश्चंस आई फेस्ड इन UGB. I am from ISI Bangalore. I did my graduation from ISI Bangalore and people have been texting me on Telegram. You can text me as well on this Telegram ID. So I love when you are actually curious. And here we go. First question. Hello everyone. Jai Hind, Sat Sri Akal. Welcome to you all. एंड इस वीडियो में हम कुछ अलग कर रहे हैं. अभी तक आपने जितना मुझे देखा है एक दो वीडियो ही हैं, बट इस वीडियो में हम कुछ क्वेश्चन सॉल्व करने वाले हैं. एंड ये क्वेश्चंस थोड़े स्पेशल है मेरे लिए क्योंकि मैं जब ISI के लिए प्रिपेयर कर रहा था इन द ईयर 2019 आफ्टर द प्रिपरेशन दिस वर द क्वेश्चंस आई फेस्ड इन UGB. सो ये 2019 के UGB पेपर के कुछ क्वेश्चंस हैं. UGB as you must know is the subjective round of ISI entrance examination. So दो पेपर होते हैं ISI entrance में. पहला पेपर UGA is an objective type. So 30 questions होते हैं. You get 2 hours and ABCD you just do them. UGB में there are 8 questions which are subjective and again you get 2 hours. And आफ्टर दैट आफ्टर क्लियरिंग दिस रिटन पार्ट उसी दिन होता है. एक UGA सुबह हो जाता है, लंच के बाद दोपहर को UGB होता है. एंड वी हैव टू राइट फुल सॉल्यूशंस एंड आई विल ट्राई टू टेल यू दैट व्हाट आई वाज लुकिंग फॉर इन दीज क्वेश्चंस. एंड it might be very simple for you, it might be tough, and in either case I hope you'll have something to learn from this video. And without much time, let us begin. Yeah, first a little bit about me again. I am from ISI Bangalore. I did my graduation from ISI Bangalore and I did my masters from ISI Kolkata. And after that, for the past 1.5 years, I've been teaching and helping various students clear exams like AMC 8, 10, 12, CMC contest which is conducted by University of Waterloo, NMTC Stage 2 which is conducted by AMTI. And here in Vedantu I've been taking courses for Calculus Mastery which the orientation of that class has happened recently, and along with that I am also taking Olympiad Math Mastery level 5, 6 batches on weekends, on Sundays, right? हर Sunday को classes हो रहे हैं उसके. If you want to join, please join. We will have hell of a good time, right? And I've met wonderful people here and people have been texting me on Telegram. You can text me as well on this Telegram ID. Text me anything, some queries, something about books. Sir, I'm interested in this. So few students have been texting me and I felt so happy that sir मुझे इसमें इंटरेस्ट आ रहा है, मैं कैसे आगे बढ़ूँ, मैं क्या पढ़ूँ, आपने कैसे प्रिपेयर किया था, ऐसे करके पूछ रहे हैं एंड मज़ा आ रहा है मुझे. सो आई लव व्हेन यू आर एक्चुअली क्यूरियस. ऐसे दिखावा करने के लिए टेक्स्ट कर रहे हो, दैट इज़ डिफरेंट. बट व्हेन स्टूडेंट्स आर एक्चुअली क्यूरियस and they are asking, sir आपका बताइए क्या करूँ etc. It feels very good. So I'm more than happy to get texts from you. And here we go. First question. Again, as I said, 2019 का पेपर है मेरा पेपर. This is question 2. हमें दिया गया है एक function which takes only positive values to R and the function is defined as such. इस फंक्शन में ही एक लिमिट है. सो प्लीज केयरफुली एक बार फंक्शन को देखते हैं. इट इज cos पावर n which means this can also be written as this expression cos of 1 by n power x whole power n. थोड़ा सा क्लैरिटी के लिए एक ही चीज है बट मैंने ऐसे लिखा है. सो ये है हमारा दिया गया फंक्शन. यहाँ पे n is tending to infinity. Okay, and then we need to show it has only one point of discontinuity and इस point of discontinuity पे उसका value क्या है. We want to find the value at which it is having a discontinuity. Now you must see x is here. Function ये है x का x का वैल्यू यहाँ पे लिया जा रहा है. इट इज़ अ वेरी पेक्यूलियर फंक्शन. आई फाउंड इट वेरी इंटरेस्टिंग, तो मैं आपके साथ अभी फट से शेयर करूंगा. तो आप पहले ये देखिए, x इज पॉजिटिव, इसका मतलब n पावर x इज अ वैलिड फंक्शन. n पावर x में n वैनिश नहीं होगा, राइट? इसका मतलब n पावर x is going to go to infinity as n goes to infinity, राइट? देख लीजिए, मैंने लिखा था n पावर x अगर इंफिनिटी को जा रहा है, जब भी n इंफिनिटी को जा रहा है. इसका मतलब हम देख लेते हैं, अच्छे से लिखता हूँ यहाँ पे. सिंस x इज पॉजिटिव, it implies n power x goes to infinity as n goes to infinity, and it also implies 1 by n power x goes to 0 as n goes to infinity, which implies cos of 1 by n power x goes to cos of 0, which is 1, है ना? So this goes to 1 as n goes to infinity. तो अभी हम अगर क्लियरली देखें, so we see that the inside is tending to 1 and the power is tending to infinity, right? So I want to erase all this. Okay. So n is tending to infinity. So you can clearly see that f of x is of the form 1 power infinity. क्या आपने ये कभी पहले देखा है? डेफिनेटली हम, क्योंकि आप प्रिपेयर कर रहे हो ISI, CMI, JEE एटसेट्रा के लिए, you would have definitely seen what is 1 power infinity form. So I will write again, f of x is equal to limit n tends to infinity cos power n 1 by n power x. Chalo. Now this is of the form one power infinity. So how do we solve 1 power infinity? We take natural logarithm of that. So we will take natural log and we get limit n tends to infinity. When I take natural log of this, the n will come out. So let me write it directly, n, or maybe I'll write in 2 steps, don't worry. Cos power n 1 by n power x, which is limit n tends to infinity n ln of cos 1 by n power x. Okay, so far it is fine. यहाँ तक ठीक है. मैं क्या करूँगा, I don't want to see 1 by n here, so I just want to make a substitution. Substitute h for 1 by n, which means, and note that this is positive, and which also means as n goes to infinity, h will go to 0. All right, makes sense. So अभी मेरा फंक्शन क्या हो जाएगा? Now this becomes ln f of x is equal to limit h tends to 0, and that becomes ln n becomes 1 by h. So I'll write it later, ln cos h power x by h. Now please notice, please tell me whether it is true or not. Had it been live, I would have got an immediate response. This is of the form 0 by 0. This is 0 by 0 form because h is going to 0, because let me write h goes to 0 implies h power x is going to 0, and since h power x is going to 0, cos h power x is going to 1, which implies ln of cos of h power x is going to 0, because ln of 1 is 0, right? So this is 0 by 0 form, and 0 by 0 form implies we can use L'Hopital's rule. I think there is an S here. Okay, whatever. L'Hopital's rule, which means you have to differentiate this. I'm not interested in doing that. Let us try to do something different, right? So, okay, we have ln f of x is equal to, what did we have? We had a limit h tends to 0 ln cos of h power x by h. Okay. Instead of L'Hopital's rule, you can use L'Hopital's rule. If you want to try, you can do that. That's going to be a little bit complicated, because there are three functions, ln, cos and h power x, which we have to differentiate for with respect to h, of course. But I want to do it in a simpler way. I used Taylor series. We can use Taylor series, and ln ka to pata nahi, but cos, if you see, since h is going to 0, since we can take cos h of x to be till 1 minus h of x whole square by 2 factorial. We can take it only till that. But why? Because I mean, if you know Taylor series of cos x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on, right? If you know that, we can use it here. So I'll write only till there, and we also know ln of 1 plus t for t near 0. This is t minus t square by 2 plus t cube by 3 and so on, right? This is another Taylor series for natural logarithm. We combine the both, so we get so we can write actually this as limit h tends to 0 ln of 1 minus h power 2x by 2 by h. Is that not? Is that clear? So यहाँ से मुझे मिल जाएगा limit h tends to 0. We use this 1 plus t पे ये हो रहा है, तो t की जगह हम ये लगा देंगे. So this becomes minus h power 2x by 2 over h. Now rest of the terms have higher degrees, which is not so helpful for us right now. Okay, so I'm not taking those things. So this becomes limit h tends to 0 minus h power 2x minus 1 by 2. अब ये है logarithm of f of x. तो मैं log को उल्टा कर देता हूँ. Take another page. So f of x becomes limit h tends to 0 e power minus h power 2x minus 1 by 2. Now, where do you think is the point of discontinuity? It is clearly at x is equal to, so point of discontinuity is at x is equal to 1 by 2. It is whenever 2x minus 1 is equal to 0, right? So ये जब भी हो रहा है यहाँ पे दिक्कत हो रहा है क्यों? If I take x less than that, which is 2x minus 1 less than 0, it is x less than 1 by 2. You know that h power 2x minus 1 is going to be plus infinity, isn't it? Because h का power negative है, as h tends to 0, 0 plus पे ही जा रहा है ना, because if you see h क्या था, h was 1 by n, मैंने कहाँ लिखा वो, हाँ h was 1 by n, so it goes to 0 plus, so that's not a problem, right? दिख गया? So h goes to 0 plus, so this goes to plus infinity because this is negative, power negative है तो वो नीचे रहेगा and it goes to plus infinity, which implies e power minus h 2x minus 1 by 2, this will go to 0, right? ये infinity पे जा रहा है तो e power minus infinity मतलब e का वैल्यू कम होते जा रहा है, so it is going to 0 as h goes to 0 plus. So x less than 1 by 2 पे f of x is, so x less than 1 by 2 implies f of x is equal to 0. Similarly, if x is greater than 1 by 2, it is 2x minus 1 is greater than 0, implies h power 2x minus 1 by 2 okay, let me just write it clearly. H power 2x minus 1 is going to 0 as h is going to 0, right? h 0 पे जा रहा है तो ये 0 पे जा रहा है, and of course e power minus h power 2x minus 1 by 2 is going to 1. So for x greater than 1 by 2 implies f of x is 1, and at x is equal to 1 by 2, x is equal to 1 by 2 होने पे h power 2x minus 1 is equal to 1, so f of x will be equal to, or f of 1 by 2 will be equal to e power minus 1 by 2. तो अच्छे से लिख देता हूँ, our function is zero for x less than 1 by 2, e power minus 1 by 2 for x is equal to 1 by 2, 1 for x greater than 1 by 2. This is the function which we have. That's it. So first question solved. ताली बजाओ, ताली बजाओ, ताली बजाओ. Pat on yourselves back. And now let's go to the next question. Okay, so इस क्वेश्चन में we have for all natural numbers n, okay, for all natural numbers n, an is defined as so and so big radical. Okay, it is a big radical, it has n many radicals. There is a 2 minus, 2 plus 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 plus, rest are plus, the first one is minus, and we need to show for n greater than or equal to 2 that this is an. This is a very interesting thing, very interesting actually. Okay, and we need to show something about the limits. The limits thing, I think it is much easier to do. Now look at this, as n increases by 1, here the sine is getting theta by 2. You know, as n increases here, we are doing half of the angle, isn't it? So पहले जो एंगल था उसका आधा कर रहे हैं जैसे n बढ़ रहा है, तो वी वांट, हमें n a n पे रिलेशन चाहिए ना, तो हम इसी से शुरू करते हैं क्योंकि यही प्रूव करना था, तो इसको कुछ करते हैं और बोलते हैं कि ये है, राइट? वी यूज दिस एंड वी शो दैट a n इज इक्वल टू व्हाट इज डिफाइंड हियर. सो ओके, तो पहले हम देखते हैं हमारे पास डबल एंगल का क्या क्या फॉर्मूलाज हैं. स्ट्रेट एंड सिंपल, साइन 2 थीटा इज इक्वल टू 2 साइन थीटा कॉस थीटा. और एक फॉर्मूला है हमारे पास कॉस का, कॉस 2 थीटा इज इक्वल टू कॉस स्क्वायर थीटा माइनस साइन स्क्वायर थीटा. क्योंकि हमें साइन का चाहिए, बिकॉज वी वांट साइन, आई वांट टू फाइंड साइन थीटा in terms of sin 2 theta, right? Because this will directly translate to sin theta by 2 in terms of sin theta. I want that, but in general, take it as a rule, right? That when you are halving the angles, when you are taking the half of an angle and you want to find the relation with the trigonometric ratio of the original angle, cos 2 theta is always the good choice. Okay, cos 2 theta is, it is a very versatile formula which we get. Why? Because if I write sine as 1 minus cos square theta, I get this to be 2 cos square theta minus 1. Instead, if I write this as 1 minus sine square theta, I will actually get 1 minus 2 cos sine square theta. So I get both sine theta and cos theta in terms of cos 2 theta. So that is a good thing about this. So let us maybe find, if we find cos pi by 2 power n plus 1, we can find sin pi by 2 power n plus 1, right? We can do that because अगर तुम पीछे जाके देखोगे, if this is 2 sin, so if we find, okay, this is the homework for you, actually take it as a homework and pause the video and do it now. Pause the video, pause and verify. That 2 cos, if this is true, if true, cos this by 2 pi by 2 power n plus 1 must be equal to square root of 2 plus square root of 2 plus square root of 2 plus and so on, n plus 1 many radicals. I simply change this minus becomes plus. Check that, this is very easy, you just use cos square plus sin square is 1. Okay, not a big deal. Chalo, so if I find this, if I verify that this is root 2 plus 2 plus 2, 2 plus root 2 plus 2 root 2 plus, if this is that, then I definitely can easily get the same thing about sine. So let's see. So I want cos theta in terms of cos 2 theta. So I have 2 cos square theta is equal to 1 plus cos 2 theta. But mind you, the question asks for 2 cos pi this thing, 2 sin this pi. So I think that is fair enough because we don't want fractions. So it becomes easy. I multiply 2 again. So I get 4, I get 2 here, 2 here. So if I take square root now, I get 2 cos, and I take only positive square root because we are dealing with pi by 2 power n plus 1. Any ratio, it will be in the first quadrant, right? First quadrant. Right? Makes sense? This angle is always in the first quadrant for any n. So I am taking positive roots. Yeah, cos theta is equal to square root of 2 plus 2 cos 2 theta, which means 2 cos theta by 2 is equal to square root of 2 plus 2 cos theta. That's it. Now we actually got, let's say our Bn is 2 power 2 into cos pi by 2 power n plus 1, right? So in the previous one, this is basically a Bn. This is Bn. I am calling this Bn because An is already defined. Okay. Then what is B1? B1 is simply 2 cos pi by 4, which is cos pi by 4 is 1 by root 2. So this is root 2. B2 we use this now B2 to find because we simply have, so this simply implies Bn plus 1 is equal to root of 2 plus, this will be Bn. This is the recurrence relation which we have. So we directly use this one and we put it here and we get a recurrence relation. So this becomes a very, very simple question. So we have Bn is equal to square root of 2 plus Bn minus 1, which is equal to square root of 2 plus square root of 2 plus Bn minus 2, and I can continue doing this till 2 plus square root of 2 plus square root of dot 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 till if I am taking k radicals, then I will have, after k radicals I have 2 plus, because if I took one radical I got n minus 1, I took 2 radicals I got n minus 2. So after k radicals I will get n minus k, right? And after 2 plus square root of 2 plus square root of 2 plus, after say n minus 1 radicals, I just replace k with n minus 1, I will get 2 plus B1. And what was B1? B1 was simply root 2. So we got our answer. We got our answer in a very different way. So we got Bn is equal to square root of 2 plus square root of 2 plus so on. And we know So an square plus bn square is actually 4, which implies an, and we will again take a positive root, so we'll get square root of 2 minus square root of 2 plus square root of 2 plus square root of 2. So that's it. So this was the second question. So since I was just testing out, I only took 2 questions and solved it, and both were having some trigonometric elements of it. Oh, there is a part B as well. So we also want to find 2 power n plus 1 an, or what was the question exactly? This 2 power n an, right? So it's not 2 power n plus 1. Is equal to what as n goes to infinity? That's the question. So since we have an to be 2 sine pi by 2n plus 1. So 2 power n an will be 2 power n plus 1 sine pi by 2 power n plus 1. Now we take the same thing, like in the previous question we took h is equal to 1 by n. So let's take h is equal to 1 by 2 power n plus 1. So as n goes to infinity, h goes to 0, right? As n goes to infinity, h goes to 0 plus. So this implies this expression became sine pi h by h, and we know sine x by x, so we know sine x by x goes to 1 as x goes to 0. So we make it the same expression above and below. So this will go to pi as h goes to 0. So the limit, maybe I'll write it separately. So limit 2 power n an n goes to infinity is equal to pi. Yeah, so that's it. Now we're at the end of this session. If you like this, if you liked the solutions and the way we solved, please let me know if you want me to do some other questions, something from any exam. Just type this year, this paper, this question number. I'll have a look, and if I could find something interesting in it, I will definitely present the most interesting things here. And that's my goal, right? That's my goal, that I want you to love mathematics, and questions will be automatically done. This is such an interesting thing. It is about finding the pattern, isn't it? Even in the first question, it was about how do you convert it into 1 power infinity, and using the Taylor expansion was what made my life easier there. And I'm sure many of you would have done that. I'm glad if you did that. And that's it for now. I'll take your leave, and as requested, please let me know in the comments how this went and what else you want me to do. I'll just have a look and I'll definitely respond to that. Chalo, bye, Jai Hind, Sat Sri Akal, goodbye.